Forget Shark Week. Here on the Fighter Pilot Podcast, it's Bomber Month. Every Monday from December 2nd to the 23rd, we'll feature a different American bomber. From the venerable World War II era Boeing B-52 Flying Fortress to the cutting-edge Northrop Grumman B-2 Spirit. Never mind the announcements. Listener questions can wait. Let's get straight to the bombers with your host, retired U.S. Navy fighter pilot Vincent Aiello.
This week on the Fighter Pilot Podcast, we are talking the Boeing B-52 Stratofortress. And here to help us do that is Mr. Ken Katz, who, Ken, you're not a pilot?
No, I'm not a pilot. Well, I am a general aviation pilot, but I certainly wasn't a military pilot.
Well, all right. Do you have authority to speak on this, sir?
Yes, I do.
All right. Well, I told you I was going to give you a little ribbon at the beginning, but let's start with you, Ken. How is it that you have authority to speak on the B-52? Where are you from? What have you done? And what's your relationship with the Stratofortress?
Well, once upon a time, I was a little boy. And my dad took me to air shows, and I saw the Apollo 11 landing on television, and I thought that was the very coolest thing I could possibly imagine. And when I grow up, I was going to be an Air Force test pilot and then become an astronaut.
All right.
As a boy growing up, I turned out to be pretty good at math and science, and I built probably the world's third largest Air Force of model airplanes, and had a model rocket launch rate that NASA could only envy. And I ended up getting an Air Force ROTC scholarship to MIT, got a degree in aero and astro from MIT, and went on active duty in the Air Force as an aeronautical engineering officer.
Okay.
I was assigned to the Air Force Flight Test Center at Edwards Air Force Base, the 6520th Test Group and the 6519th Test Squadron, where I was a flight test engineer testing B-52s and avionics and cruise missiles.
Hold on, let me interrupt you. So what is a flight test engineer? So, like, for example, on the show before, we've had aviation physiological type people where their specialty is medicine, but they also get a lot of flight training. Is that something you did? I mean, you were air crew, but you weren't necessarily a pilot?
Yes. The flight test engineers are engineering officers. In the Air Force, they're unrestricted line officers, but in the Navy, they would be called AEDOs, or Aeronautical Engineering Duty Officers. It's essentially the same thing.
Gotcha.
I was not aeronautically rated. Essentially, my training was my degree.
Oh.
So after I was commissioned with ROTC, I was brought on as active duty as an aeronautical engineer in the Air Force, and we were responsible for planning tests. And in conducting tests, we might be in a mission control center or sometimes on an airplane, but air crew was an additional duty, not our primary duty. And then we would analyze the data afterwards and write up reports. So we worked as part of a team very closely with contractors and with flight test pilots and flight test navigators. And it is a really fascinating thing because if you love aircraft, then the Air Force Flight Test Center at Edwards Air Force Base is probably the coolest place in the world.
Well, it's too bad our co-host couldn't be here to participate in this interview because Sunshine attended and graduated from there.
So I had 4 years working on B-52 and associated weapons systems. When I left active duty, I went to work for the Boeing company, and I did flight testing during the full-scale development program for the V-22 Osprey.
Okay.
After that, I went to a graduate school in engineering at the University of Michigan. And in one way or another, I've been in industry since then. I right now do IT project management in the aerospace industry.
All right. So you have some in-depth knowledge on the Stratofortress, different from a pilot or other crew member. You might almost say you wrote the book on it, huh?
I have written a book about the B-52.
I set you up on that one.
Yes, you did. Thank you. I've also written a book about the KC-135 Stratotanker. And those two actually go together as a pair. Think about it this way. If it was a missile, the KC-135 tanker would be the first stage, the B-52 would be the second stage, and what the B-52 drops is the payload.
Okay.
So really, those two aircraft have to work together because the B-52 couldn't go, in most cases, do its full mission without tanker support.
Right.
So they really are two Boeing jet-powered airplanes from the same period with totally complementary missions.
Excellent. Well, then, in that case, there's no need to really dive into this topic from the point of view of hand flying the thing, although I'm assuming you had some
I've probably got about half a dozen hours of stick time and probably another few dozen acting as a navigator,
Sure.
but that wasn't my primary skill. I can tell you a little bit about flying it compared to general aviation aircraft, but I'm by no means an expert on its flying qualities.
Right. And to be fair to all the Stratofortress pilots out there with thousands of hours, let's stick with this approach for this episode, being a little more technical maybe and a little more globally thinking on the aircraft. So with that, why don't we jump right in? And now you said that you're a listener of the show. Thank you very much. You reached out to me for this. But you know the first question in our aircraft series, and that is, how did the B-52 come to be? What's the point? What was it designed to do?
Okay, when we think about engineering design, and again, I'm going to come at this as an engineer, not as a pilot, design starts with requirements. And so the requirements were to deliver a nuclear weapon at intercontinental ranges and at jet speeds. Because if you think about the two airplanes that preceded the B-52, they were the Convair B-36 Peacemaker, which was really the last big propeller bomber. That could fly at intercontinental ranges and it could deliver nuclear weapons, but it was slow. It was essentially the last iteration of World War II kind of technology, although it wasn't in World War II.
Was that with the rear-facing propellers? I think we built models of that as a kid.
That's right.
All right. Okay.
An incredible airplane, but in a lot of ways a very impractical airplane.
Sure.
The other airplane that was the predecessor was the Boeing B-47 Stratojet. The Boeing B-47 is arguably the most technologically influential airplane in history, because if you go to an airport today and you see line after line of swept-wing jets with their engines on pods beneath the wing, what you're looking at, and whether that airplane is an Airbus or an Embraer or a Boeing, what you're looking at is the essentially airplanes that are elaborations on the Boeing B-47. So the B-47 technologically was an enormously influential airplane in that it brought together jet engines and swept wings in big airplanes. But the B-47 was not capable of intercontinental range. It really had first-generation jet engines, so it was highly deficient in terms of range. It also was just being kind of the first of its kind, had a lot of other problems.
Sure.
And while that was the mainstay of the U.S. Air Force Strategic Air Command in the 1950s, it was an airplane that the Air Force wanted to do better than. And so the B-52 actually goes back to about 1946 or so, when the Air Force said, what's our next generation bomber going to look like, and put Boeing on contract.
And I'm laughing because we're still flying this thing, but
and we will be flying it for a lot longer.
But okay.
The first airplanes that the Air Force came back with, the only airplanes that could, with this technology in 1946, that could possibly do the mission were turboprops with straight wings. And they just simply didn't have the performance that the Air Force wanted.
Right.
So Boeing and the Air Force went back and forth with iteration after iteration after iteration. And there were really two key technologies that made the B-52 happen. The first of those was aero refueling with the flying boom, because you needed to have a flying boom to transfer fuel in sufficient quantities. Once you could have aero refueling, then you could have an airplane of practical size. Otherwise, the airplane had to be ginormous. The second technology wasn't actually, we think of it as the Boeing B-52, but really, in a way, the most important key technology came from Pratt & Whitney, the engine manufacturer. It was the JT3 engine. The JT3 engine was the first twin-spool turbojet.
Oh.
And previously, the jets had been single-spool, but when you went to a twin-spool turbojet, you could have enormously improved specific fuel consumption. And so you could finally have a jet airplane with jet speed that had sufficient range. The problem is that these early turbojets just didn't have much thrust. So you had to have 8 of them in order to get an airplane the size of the B-52 in the air. So the most distinctive aspect of the B-52 is that it's an 8-engine airplane. And we used to joke, or other people used to joke, if an engine failed and, the pilots had to declare a in-flight emergency, that, oh my God, the dreaded 7-engine approach.
Well, now people are used to seeing what looks like a 4-engine aircraft, whether it's a 747 or the Airbus A380, and it almost looks like a 4-engine plane because these engines are hung in what, pods of 2?
Pods of 2.
Okay.
Right.
And so I assume, we'll get to the variants in a moment, but I assume we're well beyond that first engine, and we have a bit more thrust these days, because I think the requirement I read was that they needed 80,000 pounds of thrust, and Pratt & Whitney said, oh, great, we have an engine that makes 10,000, so they said, great, we need 8 of them.
Well, yes, 10,000, but Actually, that's 10,000 with an asterisk because the J57 was the military designation of the Pratt & Whitney JT3. And the early J57s could not generate that much thrust, particularly on a hot and high situation. So what they had to have was water injection.
Oh, yes.
And you would spray in water after the compressor before the combustor. And by doing that, you would not only cool the air coming into the blades, but you would also increase the mass flow. It's sort of like an afterburner without an afterburner. It was a short-term way of increasing the thrust. And so that's how you could get the required thrust. And both the B-52 and the KC-135 use this same engine.
Okay. And so when you have a requirement to inject water, you have a requirement to carry water.
Yes, you do.
So now you have more weight.
And it's not just weight, it's also a maintenance hassle and safety hazard. Because if the water injection system didn't work, or only partially worked, you now have a real problem. In addition to that, and when we get later to sea stories, I'll tell you a story about water injection on a flight I was on. Not only that, but there's a maintenance hassle. So you've got these airplanes sitting on alert at a Strategic Air Command base, and a lot of these SAC bases or Strategic Air Command, we're up in the northern tier.
And we're talking Cold War era.
Right. So they're in places like North Dakota and Michigan that are cold in the winter. So here's what happens. You got your B-52s loaded with water, and they would carry just a huge amount of distilled water. It's getting cold. Well, you don't want to carry a big block of ice in the airplane, and furthermore, you get more thrust, as you know, when it's cold.
Sure.
So the crew chiefs would have to go out and unload the water. Okay, now it's getting warm again.
Oh,
so now we got to go out and reload the water. So the water injection, while a really neat piece of engineering, was from a practicality point of view, was a real pain in the neck.
Sure.
And if it didn't work, it also was a safety issue.
Okay. All right. So we've got water-injected engines into this giant aircraft designed to carry nuclear weapons, essentially, strategically.
That's right.
And I'm sure there's more to this.
There is. Remember that the nuclear weapons, particularly the early kind that the B-52 was designed around, are big things. They're not like 500-pound bombs. So you have to carry the bombs basically at the center of gravity of the airplane. Otherwise, you would have a huge pitch trim change when you drop it. So the requirement for a big, uninterrupted bomb bay means that you can't have the wing carry-through structure getting in the way. So you have to have a high wing. And if you're going to have a high wing on the airplane, that leads to a couple other things. The first is that you can't put the landing gear hanging off of the wing. So the B-52 has quadricycle landing gear. It has 2 landing gear on the fuselage forward of the bomb bay and 2 afterwards.
Okay.
If you're going to have big quadricycle landing gear for these gear, and you've got this long high aspect ratio wing, and you need a long high aspect ratio wing because you want to fly a long way without much fuel consumption. So now you've got these long flexible wings, and you don't want to be dragging your wingtips on the ground, so you have to have outrigger landing gear.
Okay.
Since you have this long wing on this airplane, and you've got this quadricycle landing gear with the tip riggers, when you're landing in it and taking off at a crosswind, you can't use the wing low method.
Yes.
So the quadricycle landing gear have got crosswind crab.
So you can steer.
And you dial in the crosswind crab instead of using the traditional crosswind landing technique that most pilots of airplanes are used to doing. So it all goes back to how do we have a high-speed, long-range airplane with the engines that were available in 1948, which is when the design as we know it stems from, and how do we have this long, uninterrupted bomb bay, and everything else flows from that.
Ken, we frequently say on this show that aircraft, as with many things in life, are a series of compromises. So or trade-offs even. So it sounds like the B-52, I mean, you start with, what do we want this thing to do? Well, that means it has to have this. Well, if we have that, we have to have this, and this equals that. And of course, it's very generic what I'm saying right now. But the point is, you end up with something that looks like what now the B-52 looks like, and you get there iteratively. Not just like, oh, let's draw this thing from scratch looking like this, but you end up there because requirements.
That's right. I mean, that's what the essence of what engineering is about, which is a combination of iteration and trade-offs. And what's really interesting, if you and the history of the design history of the B-52 has been very well documented. You know, as it goes from this straight-wing turboprop airplane to this swept-wing 8-engine jet airplane, which is what we ended up with. Which is very much, though, an airplane that is how you would design an airplane to meet these requirements in 1948. What's interesting is that a Boeing 787 or an Airbus A350 is about the same weight as a B-52. And in some ways is about the same speed and all that. But with modern materials and modern aerodynamics and modern high bypass turbofan engines, you've got 2 engines instead of 8. And you have an airplane that can do the missions that if you were to, say, make a bomber version of these airplanes, that could do basically all the missions of a B-52, but with no air or refueling. So it shows you how much technology has advanced since the B-52 came around.
Well, and I can only imagine computer-wise the advances. I'm not even sure initial B-52s had it. So now that's good. We've talked a little bit about why it looks the way it looks. Of course, it has a rather enormous vertical stabilizer, because if you have the worst case scenario and a couple engines out on the same side, you have to be able to laterally steer this monster. Okay. Well, so it was designed for the strategic role. It's been used in a lot of other roles, and it's, golly, what has it been? First thing flew in 49, 50. So we're up to 70 years.
The B-52 first flew in 1952, and the first went operational in 1955. So it's an airplane that has been in continuous first-line service with the Air Force for 65 years, although in fairness, the airplanes that are left flying today are the ones that were delivered in 61 and 62.
But the design.
So they're only 57 or 58 years old.
That's right. All right. So in that long history, it has done many other things. In
fact,
it
has.
One could argue, thank goodness, it never did what it was designed to do. What would you say it's good at doing?
There are a lot of things that it's good at. I mean, I think that obviously the payload and range is the fundamental attribute that it has. It can carry a wide variety of weapons.
Right.
The aircraft has been amenable to upgrading again and again and again and again. And think of it as a 60-year-old house more than a 60-year-old airplane, because it's almost a shell that you can keep putting new things in, which is why it survived.
Right.
I think that in a way its greatest attribute is that it's been highly adaptable, that it can do all sorts of missions, carry all sorts of weapon systems. I think another thing that it has going for it is that it's got a large crew, which is useful for high workload situations.
And in case we forget to talk about it later, let's talk about it here, because in the event of an emergency egress, not everybody gets out of this thing the same way, do they?
That's right. The B-52 was designed to carry 6 crew members when it went into service. There was a pilot and a co-pilot. They sit up front. Then you had a navigator and a radar navigator, which was sort of like almost a World War II bombardier in role. But you had 2 navigators. They sit below the pilots, and they're in downward firing ejection seats. And then you had an electronic warfare officer who sat up behind the pilot. Now, starting with the B-52G model, the tail gun, and then you had a tail gunner in the back of the airplane who did not have an ejection seat. If he had to egress, would just jettison the turret and bail out through the hole that was made. Starting with the B-52G model, the gunner got a remote fire control system and moved up with the rest of the crew. So now you had 2 pilots in the front up top, the electronic warfare officer and the gunner in the back up top, and then you had 2 navigators below. You also could carry up to 4 additional crew members, could be instructors or. chiefs. When we operated test aircraft, we were slightly different. We didn't carry a gunner because we weren't expecting to be shot at over test ranges, and we weren't carrying electronic warfare officers. So typically, those crew positions would be occupied by some combination of instrumentation and by somebody like me.
Gotcha.
The airplanes that we flew were modified so that the gunner's position became an instrumentation operator's position. But it's nominally a 6-crew airplane. However, starting around 1993 or 4, the Air Force removed the tail guns from the remaining airplanes, and now it's a 5-crew airplane.
Yeah, I believe I read that it just wasn't a threat anymore. The maintenance and
it was an expensive thing. You got to train and pay for people. You got to maintain it, and it just wasn't really a viable defensive weapon anymore.
I should have told you I was going to ask you this. I don't know if you know. Is there any case of a tail gunner maybe in Vietnam or anywhere getting?
There were several cases where B-52 tail gunners shot down MiGs in Vietnam. I think there were 2 or 3. However, and one of those airplanes is now on display at the Air Force Academy. I believe that there's some controversy because typically in air combat, you tend to give pretty high credence to when you can get the loss statistics of the other side, what was actually shot down as opposed to what you claim. And I think that there's some controversy about what B-52s actually shot down. But I think there's at least agreement that at least one MiG was shot down by a B-52 in Vietnam.
And then getting back to the ejection sequence here, which must have been quite a sight, I take it at some point that was tested and everyone went up and down safely. I mean, obviously there was a minimum altitude for the guys on the bottom.
Yeah, there was. If memory serves me correct, it was 250 feet, but that would be pretty sporty.
Yeah.
The what you did, and now I'm trying to reach back 30 years to the ejection sequence, but I believe that what happened is that you had to be very careful because it was a totally manual system. So if everybody just punched out, then you'd have seats raining in on other people's canopies and what have you.
Okay.
There was a sequence, and I believe that the first person who punched out was the navigator. And when he opened out that hole in the bottom, then any of the additional crew members who weren't in ejection seats would go out through the hole. And then there was a sequence where the people up top in the back, the gunner and the electronic warfare officer went, and then I think the radar navigator went, and then the co-pilot and the pilot. But to be honest, I'd have to look at my checklist to remember
Probably the pilot
what it was.
went last.
Yes,
It's usually the big deal.
Right.
And probably when someone pulls the handle, he could get a book out and read because it's going to be a little while. So the crewman had to go through the gaping hole left behind the guy with the ejection seat. That's messed up. Did the crewman wear parachutes while they were in the airplane then?
You typically didn't wear parachutes. I mean, you had them available, but you didn't just routinely wear them. The parachutes were part of the seats, so...
Right, but I mean for everyone else.
No, you didn't. I mean, if you were going into a combat zone...
Sure,
but
or if
by
you had
the
an emergency.
Right, but these are long missions. You're not going to be just wearing a parachute all the time.
This is a foreign world for me. I'm strapped into my seat the entire time, back when I was...
That's right.
These guys are... different story.
But it's not like the B-52 is all that luxurious inside. I mean, it's for a big airplane, you're really cramped and what have you. But yes, you can stretch out. And on long missions, you could certainly carry extra crew members and people could roll out a sleeping bag.
And they probably had a latrine and a galley and various...
You didn't have a galley, but you did have... Although I think that some of them did. I don't recall us ever doing that, but they did have, latrines and what have you.
Particularly with aerial refueling, these aircraft could fly almost all day long. I mean,
they could fly longer than that. I mean, during the Cold War, up until 1968, they flew missions called chrome domes. Chrome domes were airborne alerts with live nuclear weapons because they didn't want to get caught on the ground.
So they were up there 24 hours a day.
Excuse me. They were flying 24-hour missions. They had 3 profiles. One of them was around the periphery of the North American continent. That was a 24-hour mission. The next one was out to the Mediterranean and back. And then there was a third one called Hardhead. And what Hardhead was up to Greenland, and they would orbit from around the ballistic missile early warning system radar site up there. And the reason why they did that was that, let's say that site went off the air. There was 2 possibilities. Their radio broke or they had just been attacked.
They were no longer there.
Right, as part of a surprise attack. So the reason why you put an airborne alert is if the BMU site in Greenland lost touch with the United States, they would call up to the B-52 and say, hey, did you see a bright flash down there? If yes, they would say, go. And if not, they would say, we better work on the radio. But, those were 24-hour missions. And then you have to remember, at the beginning of Desert Storm, there was, back in 1991, there was a mission using conventional air-launched cruise missiles, which launched from Barksdale Air Force Base in Louisiana, went all the way to Iraq nonstop with aerial refueling, launched missiles, and then came back. So I believe that was more than 24 hours long, that mission. It can fly very long missions. I mean, really, the limiting factor is probably the engine oil.
That's crazy. Ken, I'm going to be 49 this year. You look like about my age. I don't think the generation today understands what you and I grew up with. Even in the 80s, that was a deal. Now, you talked about Chrome Dome in the late 60s. And of course, you had the Bay of Pigs and some of the other issues with that really made it feel like it was on the brink. And I wasn't around for those. But I remember the Cold War still existed and we had various stages of alert, and the world is a different place now than it was back then. But to think that there was something airborne all the time with nuclear weapons, that's crazy.
Well, it was crazy. And in fact, it stopped in 1968 because we had too many accidents.
Of those airplanes?
Of those airplanes. In fact, with live nuclear weapons on board. We had one that had an accident where a B-52 had a collision with a KC-135 over Spain and dropped 3 nuclear weapons on Spain, which fortunately didn't go off, and one off the water. Then we had one where we dropped them in Greenland. and we had a bunch in Conus. So in 1968, they said enough with that, and they stopped the airborne alert. In theory, they could have resumed it in some extreme crisis, but I actually believe, and mostly because it's fun to bust on my fighter pilot friends, but partly in all seriousness, that the B-52 is the most important military airplane that the United States has ever built, because the B-52 was our primary means of deterrence, particularly until the missiles came in force. And it prevented World War III. And World War III during that period would have gone nuclear. And none of us would be here anymore. And so that mission of deterring, a war that would have ended civilization as we know it, I really think is the most important mission that our U.S. military has ever had.
Sometimes, Ken, when I listen to the interview, enough situational awareness now that I can listen for little things that I like. And sometimes I listen for what could be my opening bumper before the music. And I think I just heard it because I think that's as good a summary of the aircraft as any. And of course, it's impossible to know what didn't happen, right? But we know the war didn't happen, thank goodness. And the B-52 certainly played a big part in that. So I would agree with that. All right, well, let's move on to the variants. And there are several. We don't have to talk ad nauseum of each one. But for example, I think the A was mostly a prototype. There might have been some, but anyway, you can walk us through it.
Sure. Well, the first two B-52s were the XB-52 and the YB-52, and they're really distinctive because they have a bubble canopy, and the pilot and the co-pilot sit in tandem under that bubble canopy like on the B-47. The first one flew in 1952, and General Curtis LeMay, who was the Commander-in-Chief of Strategic Air Command, didn't like that. So the major thing, and those were the prototypes. So the B-52A, and now only 3 B-52As were built, and they were actually used for testing. They never were operational. But the B-52As went to a conventional side-by-side cockpit. They also added the water injection. Other than that, they were very similar to the XB-52 and the YB-52.
Because X is like a test airplane, right?
And Y is like a prototype. Kind of that's right.
So then we get the plain old B-52, and then the A is the first variant. And now, well,
actually, the B-52A was there was no B-52. That's just generic. You went from the XB-52 one built, the YB-52 one built, and then 3 B-52As.
Okay, gotcha.
And which were only used for tests. Now, the first model to go into production was the B-52B. There were 30 of them built. It went operational in 1955. They were also used heavily for testing because the airplane still had a lot of work. And many of those were actually built as what was called RB-52Bs because, which is to say reconnaissance airplanes, they weren't carrying bombs. They were carrying pods in the bay that carried cameras and recon operators. And the reason is because we didn't have satellites back then. We also didn't have U-2s. And if we were going to bomb the Soviet Union, we would first have to find out what we were going to bomb in case of war. And so strategic reconnaissance was actually a more important use for the airplane at first than bombing was.
And the technology back then was probably such that to get a good picture from so high up was pretty large equipment. And so a large aircraft had to carry it.
And with all the range and everything. That's exactly right. So the B-52B, which was the first one to go operational and also did a lot of impressive things like it was the first jet-powered airplane to fly around the world nonstop with aero refueling. But the B-52B had a lot of problems, both particularly in the area of avionics. And a better model came out about a year later called the B-52C. It's externally identifiable because it had bigger tip tanks. They only built about 35 B-52Cs. The first high-rate production version was the B-52D, which had some better avionics and was high-rate production. 170 of them were built. And it was built under essentially wartime levels of priority because we were spending huge amounts of money on defense in that period, and most of that money was going to Strategic Air Command. In fact, if you had looked at the Air Force, forget the Air Force budget, the U.S. Department of Defense budget in the mid and late 1950s, it was basically Strategic Air Command and everything else. And the D model was such a rush to build this airplane that they started building them in 2 factories, at the Boeing factory in Seattle and the Boeing factory in Wichita. And the D model went operational in 1956. It also was the main model that would be used over Vietnam. After the D models, the next year you went to the E model, the B-52E, which had a new bomb nav system called the ANASQ-38. And that was optimized for low-level flight because the Strategic Air Command began to realize that high-altitude flight wasn't going to work. So let's go in.
Missiles were getting better.
Right, exactly.
Interceptors were getting better.
So let's go in low, but that makes your whole navigation problem more difficult,
Right.
particularly because you need to do it in any weather, day and night. So in 1957, you get the E model. Then in 1958, you get the B-52F. The B-52F is like the E model, only you get new engines and a new electrical system.
Okay.
They built 100 B-52Es and 89 B-52Fs.
Okay.
And then the next year, you get the B-52G, which is almost a new airplane. What they did was they took the B-52F systems, its avionics and its engines and its electrical system, and they put that in a new lightweight airframe. So the tail gunner's position moves up with the rest of the crew.
Okay.
The airplane gets a short tail. So if you look at a G model next to any of the one that precedes it, it's noticeably shorter in the tail, which is the dead giveaway. The airplane had no ailerons. They just went to straight spoiler roll control. And that goes in 1959. The F, by the way, model was the last model that was built in 2 sites. Starting with the G model, they built them all in Wichita because in Seattle, you started to focus on the KC-135, which, as I said, is the stablemate.
That's right.
Now, the G model was built for a few years. It was the most produced model at 193 build.
Okay.
And that probably should have been the end because the Air Force was going to go to the B-70, which was its Mach 3.
The Valkyrie.
Exactly.
Mm-hmm.
But Boeing said, well, hey, you might have some trouble with the B-70. So why don't you just build an interim B-52 to keep the fleet full while the B-70 comes in? So delivered in 1961 and 62 was the B-52H, which is the ultimate model. It was sometimes known as the Cadillac. And 102 of those were built, and they were distinctive in 2 ways. It was basically the B-52G, only now you got TF-33 turbofan engines instead of the J-57 turbojet. So you had longer range, you had better takeoff performance, you didn't have to do water injection. You also, the defensive armament, instead of being quad 50 caliber machine guns, was now a 20 millimeter Gatling gun. And those interim airplanes, which were just built for a few years until the B-70 came in, are the airplanes that we have today and will be flying probably through 2050 at least.
So I did hear that this could be the only aircraft in military service to have a 100-year operational life.
That's right. That's right. Although I would be interested to see if some of the KC-135s might last that long. But yeah, this one will do that. There is now another model that may be coming, which is the B-52J. And what the J is that, the B-52 is using these TF-33 engines from 1960 era. Their fuel consumption is very high, and they have a high, they're expensive to maintain. So the Air Force is right now talking with, the usual engine manufacturers to see if they can replace them with 8 modern turbofan engines. Now, you would think, well, why not just 4? It has to do with things like if you go from 8 engines to 4, a lot of things have to change, and you've got problems in the with control in the one engine out situation. So they're going to put in 8 engines, but they're going to put in 8 modern engines, probably the kind that would go in business jets. If they put in that, they're probably going to redesignate it the B-52J.
But it would be an older airframe, most likely.
Same airframe.
Right? They're not building these.
That's correct.
Okay. So if my chicken scratch here is correct based on what you were saying, looks like about 750 of these built overall?
Yeah, 744, I think. So your math is very good.
Right. And like you said, a handful of these still flying, I believe, in Barksdale in Louisiana? And
Minot in North Dakota.
Okay,
They're
and then
there's
Fort
also
Deployed.
my old squadron at Edwards Air Force Base typically has 1 or 2 at any time. So there are about 75 of them, I believe, that are still active today. There's some in the boneyard, and some have been trited over the last 57 years.
Well, of course. Well, they probably put some in the boneyard that came back out.
Yes, they have done that. They've done that at least twice. The H models went in, and then they pulled them out.
And then is it a particular B-52 that does some of the test work where, like for the X-15 and some of the other things where you see something fall off it, it dropped off, obviously?
Great question. One of the B-52As, 52-003, known as Balls 3, was redesigned or was rebuilt as the NB-52A, and one of the B-52Bs, 52-008, known as Balls 8, was modified as a mother ship. Both those aircraft were used for the X-15 program. They were operated by the Air Force and then given over to NASA. Balls 3, I believe, was retired with the end of the X-15 program in 1969 or so. Balls 8 continued in service with NASA to about 2008, it's now on display at Edwards Air Force Base. Its last program was the X-43 hypersonic airplane. So yes, those two are in some ways the most famous B-52s and have been used for really cool research missions.
Is the B-52 used today in that same capacity?
Yes, it is. When, for example, you've got a few years ago, you had the X-51, which was another hypersonic bed, and my old squadron, Edwards, took a B-52H and several B-52Hs and used that. Coming up, you're going to have flight testing of some of these new hypersonic weapon systems. And again, the B-52 is a great mothership.
Okay. All right. Well, we've talked already about the features. Anything else there we didn't talk about? I mean, it's obviously quite a complex aircraft, but it is very distinctive looking, I would say, as well. So anything else on the features?
Well, even within a certain model, particularly the G and the H models, which lasted in service so long, they've really evolved. Even externally, you can see it. One of the changes has been what's called EVS, which is the electro-optical viewing system, which is a FLIR and a TV, and you can see these bumps that grow under the nose.
Okay.
There are also lots of other lumps and bumps that have appeared on the airplanes over the years due to things like different communication systems and ECM systems. Right. So if you took a B-52H and put it up against a B-52 stock when it was delivered in 61 or 62, you'd notice that the airplane looks substantially different. Also, by the way, it's added drag and empty weight over the years because of that.
Of course. And that is always the trade-off. But if the equipment's worth it, then I suppose that's the trade-off they're willing to make.
That's right.
All right. So armament-wise, we talked about the tail gun. Maybe it's easier to start with defensive before we go to offensive. So I presume chaff and flares and...
That's right. You started off... Actually, a few of the early B-52Bs had twin 20-millimeter cannons, but that didn't quite work out, and they went to the quad 50s, which were used from the late B through the G models, and then the H models got the 20-millimeter Gatling gun.
And did I read correctly? Is it the M61? I mean, that's the same gun in fighters.
That's right.
All right, so they had some system for the guy to use that. That must have been pretty cool.
The first weapon that was used on the B-52 offensively was the Mark VI. The Mark VI was essentially the high-rate production version of the Mark III, which was the bomb that was dropped on Nagasaki.
Okay.
But the Mark VI was supplemented pretty rapidly by the Mark 15, which was the first, quote, lightweight thermonuclear weapon in the megaton range. That was kind of the mainstay at first of the B-52, and you could carry two of those weapons inside the airplane. Then in the late 50s and early 1960s, it got a whole string of additional thermonuclear weapons. You got the Mark 21, the Mark 28, the Mark 39, the Mark 41, the Mark 53. They were all thermonuclear weapons. The most common of those by far was the Mark 28. Thousands of those were built. They were small enough that you could upload a four-pack, if you will, kind of 2x2 in half the bomb bay. The most powerful of them was the Mark 41. They didn't build very many of them, but it was 25 megatons. I don't even know what you would do with a bomb that powerful. But it was ridiculous. But that was the most powerful weapon. You also started to get missiles on the airplane, starting with the G model. You had the Quail. The Quail was a decoy, and a typical load would be 4 Mark 28s and 4 Quails inside the bomb bay. And then you had something called the Hound Dog, which was an early air-launched cruise missile. You would carry those on pylons under the wings. The Quail was jet-powered. It carried a W-28 warhead, which was essentially the missile warhead version of the B-28. And it was stellar inertial guided. These early missiles weren't very good. They weren't reliable. The electronics just wasn't up to it.
It was a start, though.
Yeah, it was. The Hound Dogs added a lot of drag to the airplane, being carried on the outside. They weren't very accurate. But, it was an initial attempt to put standoff weapons. The Hound Dogs were originally fitted on the G models, and then they were fitted on the H's later and on the earlier models. Another weapon from that era was called Skybolt. It was an air-launched ballistic missile. You were going to carry 2 of them under the wing, under each wing of a B-52H, but Skybolt was canceled. But the H model was originally built primarily as an air-launched ballistic missile carrier.
So you would drop this thing, would fall a little ways, fire, go up into the atmosphere.
And come down. And
okay. Wow.
But that never went into operation.
Okay.
And then, of course, in the B-52 era, you get into conventional arming of the airplanes. The B-52Ds were modified with something called Big Belly mod, and they could carry somewhat more than 100 either Mark 82 or M117 conventional bombs, plus you could carry them on the wings. and those were used for arc light and for linebacker. So the B-52s are D models are very distinctive in the Vietnam era and then through their retirement because they were painted with camouflage on the top and black on the bottom.
Oh, yes.
And they had this big belly modification.
This is where the term carpet bombing was generated,
That's
guessing.
right. And it probably wasn't all that effective, but it sure caused a lot of destruction.
It was in Desert Storm, as I understand, if psychologically, if nothing else.
Well, Desert Storm was a little different because we had much better intel on the targets.
True.
But in Vietnam, they caused a lot of damage, but they obviously weren't particularly decisive in the grand scheme.
Okay.
In the 1970s, you started to get some additional weapons on the airplane, one of which was the B-61, which was a thermonuclear weapon that was optimized for high-speed, low-altitude delivery. So it started to replace the earlier weapons. It also was a small weapon, so you could carry this 2x2 clip in half the bomb bay. The other half of the bomb bay in the G and the H models got something called SRAM, which was the short-range attack missile. It was a supersonic missile. It was not particularly accurate, but it was fast, and it was fairly reliable. And what you used a SRAM for was defense suppression. So you would know where the SAM sites were and where the radars were, and you would, as the B-52s would ingress into the target, obviously hypothetically, thank God this never happened,
Yeah, exactly.
you would be firing these out, and if you're going to suppress a SAM site with a thermonuclear weapon, you're probably going to shut it down. So those airplanes, the G and the H models, got a new set of weapons in the 70s. Now, the biggest weapon, though, that came starting with an IOC in 1982 was the air-launched cruise missile, because the B-52s were going to be replaced by the B-1A. But President Carter canceled the B-1A in 1977. The calculation is that B-52s carrying air-launched cruise missiles were more effective and certainly more cost-effective than the B-1 was. So the B-1 got canceled, and B-52's G and H models started getting air-launched cruise missiles. In order to carry air-launched cruise missiles, they also needed to have a new digital bomb nav system. So in the 80s, you got the air-launched cruise missile. You got a very classified weapon called the CALCM, or Conventional Advanced Cruise Missile, which was the advanced cruise missile with the nuclear weapon taken out with a conventional weapon and GPS. And that was what was first rolled out in Desert Storm.
Okay.
You got a follow-on to the air-launched cruise missile called ACM, or Advanced Cruise Missile, which was stealthy and had better nav and a better engine. And I was involved in testing that. That only went operational after the end of the Cold War, but would have been an incredibly lethal weapon, because now you can have an airplane that can launch a dozen of these, and you can't see them. And the first time you know that they're attacking you is when you get this really bright flash.
Yeah, that's bad.
So,
on that note, just real quick, the B-52 itself is not at all stealthy.
Oh, no, it's the most unstealthy airplane in existence. And in fact, one of the major deficiencies of the airplane is that you can only use it in a permissive air defense environment. So you either need to stand off or be dropping smart bombs on the Taliban that can't hit you at 25,000 feet.
Right.
It carried, for the time, a very good electronic countermeasures system, but the basic radar cross-section is immense on the airplane.
Sure, yes. Not at all like the B-2, which we will speak of on another episode. Okay.
That's right.
Sorry, back to armament.
Okay, so you also got another bomb in the 1980s called the B-83, which was fairly small, but it was of the megaton range, and it was designed again for high-speed, low-altitude. It also would eventually go on to arm, like with the B-61, the B-1, when that was brought back as the B-1B and the B-2. The B-52 started to carry Harpoon anti-ship missiles.
Right.
Now, all of them didn't carry that. Only a few were modified in squadrons that were tasked for that. It carried the CBU-87 cluster bomb, which was the primary weapon that was used in Desert Storm, and that was incredibly lethal against Iraqi armored formations because you carry just...
And each one of them opens up hundreds of bomblets inside.
That's right.
So that had to be destructive. Wow.
And it was phenomenal. Then there were a couple of weapon systems which were tested but never went operational, which I worked very closely on. The first was called Tacit Rainbow. It was a air-launched defense suppression weapon. It was essentially a little cruise missile, 500-pound cruise missile with a conventional warhead, with a radar-seeking warhead like the HARM, and you'd carry 30 of them on a rotary launcher in the bomb bay. And you would launch them out, and the theory is that these would fly on pre-programmed paths and suppress the enemy. And if he turned off his radar because he was afraid of getting attacked, your strike aircraft got to sail through. And if they didn't turn off their radar, then they would have these little missiles diving on them. And I spent most of my active duty testing Tacit Rainbow, actually.
Okay.
The other missile that was tested was a very, very classified missile called TISM, or a Tri-Surface Surface Attack Missile, which was a highly accurate, highly stealthy conventional strike missile. There's been one picture released of it, no information on what it had.
Obviously, you're allowed to talk about it now.
Its existence has been declassified,
Okay.
but it was canceled because, like Tacit Rainbow, it ran into some trouble. Then the Cold War ended and funding was cut off,
Okay.
and that party was over. The B-52 continued to get new weapons in the 90s to this day. So the most important weapon it got was JDAM.
Right.
It got a WICMID. The WICMID was the wind-corrected munitions dispenser. So it's cluster bombs that have inertial guidance on them. It got sensor-fused weapon, which is a version of a cluster bomb that drops these skeet for attacking armored vehicles.
Mm-hmm.
It got the paveway laser-guided bombs. HAVNAP, which was a precision-guided weapon. It was actually an Israeli Popeye missile. You carried a guidance pod on one wing and then two of these big missiles on the other end. And it was actually manually guided in by the radar navigator, so you could put it through a window.
Oh, gosh.
It also had an INS on board.
Right.
You had JASM, which is the stealthy joint
air-to-surface standoff missile.
There you go.
If I remember correctly.
And that's one of the primary weapons of the B-52 today. And that fits the airplane very well because it's a standoff weapon. You have MALD, which is the miniature air-launched decoy.
Right.
And then you got the next things which are coming, which are hypersonic missiles.
Oh, gosh.
So you can strike things, from hundreds of miles away at Mach 6. Then another weapon that's coming is if the political people who run our government decide to go ahead with it, it's called long-range standoff missile. That's going to be a cruise missile that replaces the air-launched cruise missile, which is still in service today.
Mm-hmm. Okay.
And that's pretty controversial for a variety of reasons. But if long-range standoff missile doesn't get approved, then the B-52 is going to lose its nuclear mission because the ACMs the ACMs were retired a decade ago. The ALCMs are quite old at this point.
Okay. Now, what about a JSOW to go with the JDAM?
The JSOW was tested on the B-52 by my old squadron, but it was never fielded.
Okay. And how about mines, like underwater?
Yes, thank you. Okay. I missed that. It's one of our primary platforms for mines. I believe the mine is called a Mark 62 Quick Strike, and it's basically a Mark 82 with a kit on it.
And the proper protection for being underwater.
That's
All
right.
So I'm thinking a 500-pound bomb, which is about as small as they get, inside and outside. How many can this thing carry?
And I'm working off of memory now. I believe that the H models can carry 27 internally, and then externally, I believe now it's 6 per side.
Okay.
But I'd have to check. One of the things that's also changing is that very rarely in 2019 would you carry straight Mark 82s.
Sure.
They're almost all the GBU 38 JDAMs these days.
But still close to 40 air-to-surface munitions.
That's right.
Theoretically.
That's
or
right.
One very big one. So this thing can do it all, and it has done it all. I mean, it's been in every armed conflict since Korea, right?
It's been in at least every major armed conflict. In a way, the definition of a major armed conflict is we bring in the B-52. Because it wasn't used, of course, in Grenada or something like that. But it was used in Vietnam. It was used in Desert Storm. It's been used in Kosovo.
Right.
We also did some attacks with them on Iraq in the 90s. There were several of those. Then, of course, it was with Afghanistan and Iraq, and since then, all the conflicts that we've been in.
So this is a strategic asset to the United States.
Very much so. And
whether it's nuclear equipped or not.
It's just a really adaptable aircraft that's done a lot of things. And that's, I think, why it's had the longevity that it's had.
Sure. Now, with the size of the fuselage, certainly the early motors and the wings, everything else, I'm guessing it's not going to perform like an F-16. But what have you seen, or what anecdotally can you tell me about the performance? I mean, we have high flying for some missions. They had a low altitude mission for a while. How about speed, altitude, range, Gs, or what have you done anyway?
Yeah, no, it used to fly low-level missions, but low-level missions required a lot of training, and they really beat on the airframe. So the Air Force hasn't done low-level in the B-52 for quite a while. But it was fun. I used to enjoy, particularly on proficiency flights, sitting on the jump seat between the pilots. what we did low level, and it was a blast. The airplane, I recall that it was limited to 390 indicated.
Knots?
You could get up to knots. It could get up to, I believe, about Mach 0.84 at high altitude. So it's a kind of a reasonably high subsonic airplane, but not a fast airplane. It could get up to about 50,000 feet, although if you were loaded with fuel and bombs, and particularly as it's gotten more drag over the years, I think it'd be pretty tough to get up to 50. But a lightweight B-52 could probably get up to 50 feet. 50,000 feet. Yeah, thank you. Maximum gross takeoff weight is 488,000 pounds for the G and the H models, somewhat less for the early models.
Okay.
And of that, about half of it's fuel.
Sure.
The unrefueled range depends on a lot of factors,
course,
obviously, but might be as long as 7,500 nautical miles.
Okay. It depends on winds and loads and so many
and all
things,
that, right? And particularly if you're carrying external stuff on the wings, the drag goes up pretty rapidly.
Speaking of that, earlier you said tip tanks, and I made a note to come back to it. So that's those most outboard little, they almost look like drop tanks on an F-18.
Right.
But they're not jettisonable.
No, they're not jettisonable. In fact, they serve a couple purposes. Not only do they carry fuel, but they also have to do with aeroelasticity and avoiding flutter. So they serve that purpose. And in fact, the major job of a co-pilot on the B-52, remember, it doesn't have any sort of automated fuel system. This is an airplane from the pre-computer age. And so it's got an enormous number of fuel tanks, and there are an awful lot of considerations ranging from flutter to CG. And the co-pilot spends probably more time acting as a flight engineer moving the fuel around than anything else on the airplane.
Okay. That person is the automated transfer system that we take for granted now, at least on the airline
That's right.
that I fly. And what do you recall is the total fuel capacity in pounds? Am I putting you on the spot?
You're putting me on the spot.
It's been a long
time.
It's at least 80,000 or more.
Oh, of fuel?
Yeah.
Oh, no. The fuel is probably half the weight. I don't recall the number, but I believe it's well over 200,000 pounds of fuel on the airplane. Wow. I mean, it's at takeoff, it's like half fuel. And it's more fuel than anything else. So, I mean, it really is a flying fuel tank. And it's a fairly big airplane. And once you get with the fuel and the bombs, there's not much room for the people. It's actually, for a big airplane, it's a pretty cramped, uncomfortable airplane. Now, a fighter guy would think that, it's commodious. But by any other standard, it's a pretty cramped airplane.
And continuing with performance, I'm guessing with those giant wings and big aircraft, not a lot of G-force.
No. I don't recall the number, but it's something like a 2G airplane.
Right. Okay, that's what I would expect. And then again, down low, you're going to get bounced around a lot by the turbulence down there. But it sounds like they don't do that mission anymore.
No, they don't. But between the fact that it was really designed as a high-altitude airplane and has the wing loading that's appropriate to that, and it's a big, flexible airplane. And remember that other than the pilots, nobody's got a window, so the B-52 is the best device for inducing air sickness that's ever been designed. I tend to be prone to air sickness, and I always flew with a full set of bags. The mark of a good instrumentation operator was that you could get the mission done even if you, despite everything else, you just had to manage your stuff in the cockpit well. But no, it was a miserably uncomfortable airplane to fly low level in.
Okay. Now we come to the part where we talk about strengths and weaknesses. And, I don't know, when I first came up with the aircraft series, I thought about putting this in there and obviously did, but it has caused consternation with some of our guests in the past because a strength it all comes with a territory. In other words, well, it's a bomber. So is the only 2G limit a weakness? No. Compared to an F-18, it is. But I guess what maybe I should refine this question into is, what did the pilots or aircrew always rave about for the airplane? And what was the one thing they wished that someone would get their T-Rex arms out and reach their wallet and pay for to fix? I mean, are there simple answers to those?
Well, I think that the real problems the airplane's strengths are its range, its payload, its ability to handle a large variety of weapons, its flexibility and ability to be upgraded. The problems with the airplane or the weaknesses are inherent to an airplane of that era. So, for example, what are some of the weaknesses? High fuel consumption because it's got antiquated engines and antiquated avionics. So it's heavily dependent on tankers, and it just burns a lot of fuel, which is expensive. This is an airplane before you had high bypass turbofans. It's an airplane before you had thrust reversers. So it's got water injection and a drag chute. That's a maintenance pain. It's got no APU. That wasn't a big problem when it was being based out of SAC bases where you could have all this ground support equipment. But when you have an expeditionary Air Force that's operating out of a lot of places, now you have to bring a lot of ground support equipment.
Right.
That's not a pilot hassle per se, but it sure is a maintenance problem. As we all know, maintenance drives aviation at least as much as operations does.
So without an APU or auxiliary power unit, you rely on an external cart to start the aircraft.
That's right. Or starter cartridges in an alert situation.
Okay.
But, not having an APU is a significant problem. Because the airplane has outrigger landing gear, it needs very wide runways and taxiways. SAC bases have at least 200 or 250 feet wide runways. But for example, when the B-52 a couple years ago was brought to Oshkosh for the big air show up there, they had to remove the landing lights on the runways and the taxiways because otherwise the outriggers would have taken them out.
They're going to knock them over.
That's right. So it's very limited on the number of airfields that it can use, which is a real operational constraint. It's got a crew of 5, and if you were to design an airplane like that today, you wouldn't need 5 people on board. So that's expensive. It's got an enormous radar cross-section. It's not survivable against modern air defenses, even though it has a fairly elaborate electronic warfare system. If you're in a non-permissive air defense environment, you really have to be standoff.
Okay.
And it's got downward-firing ejection seats for the nav and the radar navigator, which obviously have a limited envelope.
Right.
It's not that, if only we could fix these things. These are the issues of flying a very old airplane. Sure. It's not a wonder airplane. It's an adaptable airplane, and I guess most importantly, it's paid for.
There you go. Well, and it has done its job very well, I would argue. And as with any aircraft, you find a way to work around its shortcomings or weaknesses. Okay. How about notoriety? Now, I think anyone listening to this show can conjure up a mental image of a B-52. It's pretty well known. But for the wife who's sitting in the car with the husband on a road trip and he's into his 3rd episode of the Fighter Pilot podcast and they're listening to this one on the B-52 and she leans over and says, "What is that?" Where might she, and I'm picking on, I guess, the ladies here, but I'm sure there are a lot of ladies that know him, but where would someone who's not an aviation aficionado have seen a B-52, whether in the news or in Hollywood or anywhere like that?
Well, you have the movie Dr. Strangelove.
Okay, so Slim Pickens rides the bomb out of the B-52.
That's right.
Okay.
And you have the music group, the B-52s.
Oh, very good. Have they ever done anything, though, album artwork-wise? I haven't seen anything.
I don't believe so.
Okay.
But obviously they didn't pick that randomly.
Okay.
And just in general, it has even though it's an old airplane, it has an intimidating reputation. When the United States is sending B-52s,
that's right,
it's a certain way of saying we mean business now.
Indeed. And it has a very distinct shape with those 8 engines and the large, high swept wing and the big tail. And yes, it is menacing, I think is maybe the best word for it. Okay. And I think we said it earlier already, but 100-year service life, possibly.
Possibly, if they're going to re-engine the airplanes, you got to operate them for a while to get a return on investment.
That's true.
One of the things that the airplane brings to bear is because it can carry weapons externally, unlike, say, the B-2 or this B-21 Raider that's coming, you can carry big things like these hypersonic missiles that a B-2 can't carry. And so, paradoxically, if you look at the current Air Force bomber roadmap, the B-1 and the B-2, which were both purchased partly to replace the B-52, are going to be retired from service before the B-52 gets retired from service. The B-21 Raider will replace the B-1 and the B-2, not the B-52. The B-52 may very well last past 2050.
That is a testament to the design and to the requirement that there exists to do, like you said, to have, if nothing else, the test that is required of various aircraft to be released from the B-52. Now, you having written a book, and in case I forget to later, why don't you tell us the name of the book, and then I'll look it up later and throw it, by the time the listener hears this, on our website so they can buy it. I assume it's available on Amazon, but what is it, and what's the story behind the book?
The book is called The B-52 G and H Stratofortress in Action. It's published by Squadron, and many aircraft fans are familiar with the Squadron in Action series, which started in the early 1970s and is now, I think they've done like 250 volumes of that series.
It's like the blah, blah, blah for dummies thing, right? In other words, like anyone can write within this genre and it fits a certain template? Is that true?
There's kind of a certain template. I don't know if it's for dummies. Some of the books are really quite good.
No, I didn't mean that way. I meant like, real estate for dummies or Shakespeare for dummies. I mean, there's a whole series of blah, blah, blah.
That's right. It's very much there's a formula that they have that's proven to be very successful. It's largely photo-based. They've done several ones on the B-52 in the past, but they really needed an updated one, so I focused on just the G and the H model. Okay. It's now in its third printing, and every feedback that I've gotten on the book is pretty positive.
Good. Well, like I said, we'll proudly list it in the notes for this episode as well as on our website. Now, in the writing of that, or in your experiences elsewhere, is there a good story you can share with us, either where the B-52 surprised you or saved you or any other excitement you can share with us?
Well, I've got a couple fun stories. The first was, that illustrates the low power of the early jet engines. Okay. I was based at Edwards Air Force Base, which has a field elevation of about 2,300 feet and is incredibly hot. And we were taking off on a test mission in a B-52G, which had the old turbojet engines. It was 2,300 feet field altitude, and it was hot. So the density altitude was probably 5,000 feet or so. And we knew that the water injection system was not working on the airplane.
Okay, so that was already griped with maintenance.
That's right. And the reason we could take it is because Edwards Air Force Base has one of the longest runways in the world. Our ground run was 14,000 feet. We were at max gross weight. I was sitting in the gunner's seat. I had my hands on the ejection handles because if this thing was going to run off the end of the runway, I didn't particularly feel like being in it at the time.
Yeah, but your two buddies down below you aren't going to do too well in that scenario.
No, they weren't, but I didn't think that I was going to contribute to their situation by being on board. So it was definitely a takeoff that I've never ever experienced before or after. That was really pretty eye-watering.
But it did make its way into the air
eventually? It did make its way.
Okay.
The calculations worked just fine. We rumbled into the air after 14,000 feet of ground roll.
Wow.
That was wild. The other thing that I had, this isn't quite a Chuck Yeager flight test first, but it was for me. I was a crew member on the first launch of one of these Tacit Rainbow radar hunting missiles from the B-52. It took us a couple missions to get it off, but it was kind of neat to pickle off a weapon, not just to pickle off a weapon, but to pickle off something new and experimental.
Right.
It was very different than a operational launch. We were working with a mission control center. In fact, most of the time I was in that mission control center, but on this flight I happened to be on the airplane. My job was to make sure that all the data recordings and the cameras were going so that we could get really good data off of the mission. And after, if I recall correctly, the third mission, we finally got it off and it flew out and did its thing. So it was a very small milestone on a weapon system that got canceled, but it's mine.
It was like watching your child score a goal, right?
That's right. And whenever I now go to the Air Force Museum, there's this little orange Tacit Rainbow hanging from the roof in one of them, and no one knows what this thing is, but I know what it is.
Okay, very good. Now, Ken, this has been a really enjoyable interview, thank you. And I told you we would focus on the engineering, if you will, side of it, which we have. But I have to ask you, even if it's anecdotal from your time with your pilot friends, what was it like to fly this thing? I mean, was it a handful? Was it pretty nimble? I mean, was it enjoyable? Was it?
I have an interesting perspective on that. I'm an active general aviation pilot. Okay. I wanted very badly to go to Air Force Flight School, but because I have these thick Coke bottle glasses, I couldn't get to do that. But I was an active general aviation pilot, and because I was at Edwards Air Force Base, and in fact, I love to fly, I managed to scam flight time on all kinds of aircraft. In 4 years, I got more different kinds of military aircraft in my logbook than most career military pilots have in theirs. And so I did get to compare the B-52 to a lot of other aircraft. And at least to me, again, not a real military pilot, it's one of the worst flying airplanes I've ever flown on. It is whatever is the opposite of nimble and agile. It is. It's got
so it's a dump truck.
It's got very high control forces and a lot of inertia. And I found that I could PIO it in roll very easily.
Pilot-induced oscillations.
But I will say that its flying qualities are actually fairly good for the mission. It's a nice, stable platform for bombing. The hardest thing that B-52 pilots do is aero refueling.
I can imagine.
It's a very, very difficult thing. And when you watch a good B-52 pilot, and ours at Edwards were outstanding, do aero refueling, it's really a work of art. I mean, it's like, Blue Angel level precision flying. It's really impressive.
But it's not for only a minute or two. They're doing this for 20 minutes maybe.
That's right, because you're downloading over 100,000 pounds of fuel. But it's a very high control force, slow responding airplane. My longest flight time that I got was we had one mission where we were taking the Tacit Rainbow up to altitude for a few hours and cold soaking it before we launched it.
Okay.
That was the test point. And while we were motoring around in the Southern California skies for a few hours, I mentioned to the pilots that I thought it was unfair that they got all the flight time, and so I argued my way into the co-pilot seat for an hour or two.
Very nice.
And got to fly it. And it really was a lot of fun, but when at the time I was flying a Piper Tomahawk mostly at, 1,500 pounds, and now I had this 450,000 pounds of B-52, and I found it to be quite a challenging airplane to fly.
Okay.
It's not a sexy airplane like a fighter, but I think that pilots would agree that it's a real challenging airplane that requires really good pilots to fly well, particularly air refueling.
Yeah, I can imagine. And maybe on a high crosswind landing, although, like you said, they had the steerable thrust.
You've got the crosswind landing gear, so actually in a crosswind, it's assuming it's not a gusty crosswind, it's not bad.
Okay.
But you better get the polarity right on the crosswind landing gear.
Yes.
It'd be a real bummer if you put in 10 degrees adjustment to the left, and it really should be 10 degrees to the right. That wouldn't work out well.
And then lastly, very quickly, as far as the flight deck goes, cockpit, whatever you want to call it, obviously the early ones were all steam gauges. Did they ever end up with any kind of glass cockpit type of thing?
The cockpit up front is a collection of everything from 1950s through, there's been like laptop computers that are sort of slapped on in mounts. They added on video displays in the 1970s, which they now get some computer symbology on. The major advances have really been downstairs with the radar navigator and navigator. They started off with analog stuff. Mm-hmm. And then in the early 80s, you got the first generation digital equipment called Offensive Avionics System. And I was involved in testing that, which think of it as Apple II era avionics, but very capable, and unlike your Apple II, nuclear hardened and nuclear certified.
Right.
And then over the years, that's been steadily upgraded, and now they have more modern computers with color liquid crystal displays.
Okay.
Because when you're carrying this very large variety of conventional weapons, and you're doing things like you're able to data link information in from outside and data link information out, you really can't have 30 or 35-year-old digital avionics. So the stuff downstairs has been modernized beyond recognition. The stuff for the pilots is much more kind of a melange of old stuff and new stuff.
Gotcha. Well, Ken, this has been a lot of fun. I want to thank you for taking your time today. I've learned a whole bunch about the B-52. I guess at this point, I usually ask my guests what the future holds for them. Now, you're doing some IT work. You're still in aerospace, right?
That's right.
Okay,
That's
so
right.
Is that the foreseeable future?
I'd like to keep with my company. We'll have to see how the how the market for, because we know aerospace is very much a cyclical market, and so actually over the years I've worked in a lot of industries besides aerospace. But I'm enjoying doing what I'm doing now. I'm helping manage the development of all sorts of systems that make a big aerospace company operate.
Yep.
I'll probably do that through retirement. When I retire, I'd really like to become a CFI or a Part 135 pilot because I do love flying. Well, maybe I'll get to do that. I'm also continuing to enjoy writing books. I'm working on a book, actually 3 books right now, one about the B-1 bomber, one about the S-3 Viking, and one about the Air Force use of remote piloted aircraft.
Okay. Well, what's the next one coming out? Maybe we can help you with the launch.
I'm hoping by the end of this year that my book about the B-1 will come out.
2019.
Okay. Yeah, and that's a maybe 2020 more likely, because I do this all in my spare time. But the B-1 is a really interesting airplane. It's got a whole story of itself, which I'm just trying to piece together. But if nothing else, it's a beautiful airplane.
Well, you know what? Maybe if I end up getting the interview I'm hoping, then we'll have to run it after this episode, because that's a great segue into it. I do have a friend who reached out. He's in Denver. I just need to get out there and record that, and we will make that a compliment to this show.
I've never flown in a B-1, but I have gotten to, as researching this book, gotten to fly the weapon system trainer. And the B-1 is a gorgeous flying airplane. Okay. It is just beautiful.
Excellent. All right. Well, Ken Katz, call sign Primetime, which I never even used. You know the deal on the show. We have to find out how someone came up with that. And I don't like to normally perpetuate stereotypes between Navy and Air Force on the show, but some of my past guests have accused the Air Force of coming up with cool guy call signs. Primetime sounds pretty cool, so you're going to have to defend this one.
Yeah, it's not cool at all. First of all, Air Force people, at least the Air Force bomber people who I worked with, because I didn't work with fighter people, didn't have personal call signs back in the 80s, and flight test engineers certainly didn't.
All right.
So the closest that I have is this nickname Primetime. When I got out of the Air Force and went to work for Boeing as a flight test engineer, we were flight testing the V-22, which was a very controversial program at the time. And ABC was coming in to film a segment of their documentary, their news show called Primetime.
Okay.
And I thought that was pretty cool, and I enjoyed working with the ABC people. And so my boss started calling me Primetime.
So it shall be. It's always the folks above us that bequeath call signs on us, even in the civilian capacity. So that's awesome to hear. Well, Primetime, this has been a lot of fun. I really want to thank you for your time today and for sharing your vast expertise on the B-52 Stratofortress. If you're willing, I might talk you into a quick behind the scenes. I've got a video I think that would be a great compliment to this show. But unless you have any other parting shots, I think we can wrap it up and get out of here.
That's great.
You've been listening to the Fighter Pilot Podcast, brought to you by BVR Productions. Got a question for the show? Send an email to questions@fighterpilotpodcast.com or leave a message on our listener line at 877-MACH-101. That's 877-622-4101. Be sure to check out our website at fighterpilotpodcast.com. You can also find us on Facebook, Instagram, Twitter, and YouTube. For exclusive Fighter Pilot Podcast content, check out our Patreon page. Please like, follow, and subscribe to the show. And don't forget to share us with your network. Thank you for listening.
The views expressed in this presentation are the personal views of the host and our guests and do not represent the position of the Department of Defense or its components.